Hello and welcome to 8-7. Today we're going to be talking about polygons. Our goal for today is that you will be able to identify regular and not regular polygons. And we're also going to start talking about the angle measures of those polygons, how to figure out the angle measures of the regular polygons. We touched on this a little bit in class, so now we're going to actually learn about it. So let's get started. A polygon is a closed plane figure. Now this is the plane like it's on one plane, not like plane as in a plain sandwich or plain bread. It's a plane figure formed by 3 or more line segments. A regular polygon is a polygon in which all sides are congruent. So we need to know the difference between a polygon and a regular polygon. And all angles are congruent. So all sides and angles are congruent in a regular polygon. So this is a great table to transfer into your notes. So sides and angles, so if there are 3 sides, a regular one would look like this, a not regular one would look like this. If there are 4 sides, regular would be a square, and a not regular would just be a regular quadrilateral. If we're talking pentagons, 5 sides, this is what a regular pentagon looks like. This would be a not regular pentagon. Just 5 sides, they're all different. They don't even have to be all different, but just if they're not all the same size, then it's not regular. So 6 sides, here's a hexagon, and another hexagon, but the top one is regular. So it'd be a regular heptagon, not regular heptagon. Regular octagon, like a stop sign, and not regular octagon. Nonagon has 9 sides, not regular. And a decagon has 10 sides, regular, not regular. So this would be great to get into your notebook. Please make sure you get that in there. Now let's do some problems on this. Tell whether each shape is a polygon. If so, give its name and tell whether it appears to be regular or not regular. Now this one right here has 4 sides, so and 4 angles, so we know it is a quadrilateral. And then it asks us to say whether it appears to be regular or not regular. I would say this one does appear to be regular because it looks like it has 4 equal sides. Regular. And that is our definition. It has to have congruent sides and congruent angles. Does appear to be regular. And then we have our other shape down here. This is also a quadrilateral. So we're going to give it by, define it by its name, quadrilateral, triangle, pentagon, hexagon, heptagon, octagon. I know we've learned about classifying quadrilaterals further, but for today we're just classifying them as a polygon, so we call them quadrilaterals. And this one is not regular because it has 2 sides that are different. They're not all congruent. And the angles are all congruent, but the sides are not all congruent. So this is not an example of a regular quadrilateral. All right, let's go to the next slide. So the cool thing with quadrilaterals is, any pentagon really. You can divide them into triangles. You can divide quadrilaterals into 2 triangles, or you can divide pentagons into 3 triangles. So why that's important to us is because it can help us understand how many degrees are in each shape. Now we know a triangle has 180 degrees in its inside of its shape. So if we take a square and we pick one vertice and we make a diagonal, we would get 2 triangles, so that would be 360 degrees. If we took a pentagon, a regular or non-regular pentagon, we picked one vertice and we said, okay, I could go here, I could go here, because if I went from here to here, it'd be a line that's already there, and if I went from here to here, it'd be a line that's already there. So I can cut this one into 3 triangles. So it'd be the same as saying, what is 180 times 3? Well, 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3, plus 2 more is 5. So the degrees in a pentagon would add up to 540 degrees. Then if we did a hexagon, we could draw a let's pick this one. I mean, you could pick any vertice you wanted to. We just have to make sure we get all the diagonals we can. 1, 2, 3. So there would be 4. So then we do what is 180, because there's 180 degrees in a triangle. We'd say, okay, 180 times 4. That'd be 0. This would be 32. 4, 5, 6, 7. So that would be 720 degrees. So that's the trick on how to find how many degrees are in a quadrilateral. All right, let's try the next slide. So lastly, I just wanted to put a table on here for you to get into your notebooks that would show exactly, if I have a triangle, it has 3 sides, I can make one triangle with it, so it would measure 180 degrees. This is a nice little tool for you to have if you're trying to figure out larger shapes such as decagons, nonagons. You can figure out how many degrees are in any kind of a polygon if you have this formula or this strategy to do. So anyways, thank you for watching, and we'll see you tomorrow.